Decades after the last regular barge of garbage reached Fresh Kills, the landfill is still alive. Gas wells draw methane from beneath the grass. Pumps collect contaminated liquid. Engineers track how the ground continues to settle under the weight of roughly 150 million tons of buried waste. The trucks are gone. The dumping stopped. Yet the site is still producing heat, gas, liquid, and risk. That is the part of throwing something away that Americans almost never see. A bag leaves the kitchen. A truck takes it from the curb. By noon, the street is clean and the problem appears to be over. But nothing has ended. The responsibility has only changed hands. At its peak, Fresh Kills received as much as 29,000 tons of refuse in a single day. 4 enormous mounds rose over Staten Island. Then New York closed the landfill and began turning parts of it into parkland. So what exactly disappeared? The garbage? Or only our view of it? This is the story of how America transformed trash from a visible public danger into a hidden engineered system, and how that success helped make disposable life feel almost consequence-free. Before modern collection, waste remained close to the people who made it. Food scraps, ashes, broken furniture, animal remains, packaging, and industrial debris accumulated in streets, yards, vacant lots, ravines, marshes, and open pits. Cities burned some of it. They dumped some into rivers or coastal waters. They loaded refuse onto barges and carried it away from crowded neighborhoods. An early film of a New York dumping wharf shows horse-drawn carts backing toward the edge of a pier. Their loads tumble into a barge while workers spread the waste below. The image looks primitive now, but the logic is familiar. Cleanliness in one place depended on moving the consequences somewhere else. As cities grew, that movement became organized. Municipal crews collected refuse. Incinerators reduced its volume. Dumps received what remained. But the system was crude. Smoke drifted over neighborhoods. Paper blew across roads and fields. Fires smoldered above and below ground. Rain passed through waste and carried contamination into soil and water. Rats and insects followed exposed food. By the late 1960s, a federal survey had identified more than 13,600 land disposal sites across the country. Fewer than 5% met the minimum standards then used for sanitary landfills. America did not lack a waste system. It had a waste system that left much of the danger uncovered. Fresh Kills began inside that older world. Before 1948, its western edge of Staten Island was a landscape of tidal creeks and marsh. New York City opened a disposal site there under a plan advanced by Parks Commissioner Robert Moses. The plan was supposed to be temporary. Garbage would fill about 450 acres of wetland for roughly 3 years. The ground could then be prepared for development. 3 years. The promise sounds astonishing now, but it reflected a powerful post-war assumption. Waste could be used to improve undesirable land, solve an immediate urban problem, and then disappear into whatever came next. The problem was that New York kept producing more of it. The United States was entering an age of abundance. Supermarkets expanded. Frozen foods arrived in trays. Bottles, cans, boxes, wrappers, and new plastics made products cleaner, lighter, safer to ship, and easier to sell. Families bought more appliances, furniture, clothing, and household goods. Suburbs spread. Populations grew. The packaging was useful. The products were desirable. The waste was the shadow they cast. National municipal solid waste generation rose from about 88 million tons in 1960 to nearly 230 million tons by the end of the century. Fresh Kills expanded with that economy. Barges arrived from across New York City. Bulldozers pushed the loads into place. Compactors crushed them. New layers covered old ones. By 1971, Fresh Kills was receiving roughly half of the city's municipal waste. By 1991, after other city landfills had closed, it was the last operating landfill inside the 5 boroughs. A temporary dumping ground had become infrastructure, and infrastructure is hardest to change when millions of people rely on it without having to think about it. But Fresh Kills was not simply becoming larger. It was becoming chemically active. A landfill is not a tomb. It is an enormous, slow-moving biological reactor. At first, some organic waste decomposes in the presence of oxygen. As the oxygen disappears, different microorganisms take over. Food, paper, yard waste, and other organic material continue breaking down without air. That process produces landfill gas, much of it methane and carbon dioxide. Methane can burn. It can migrate through soil. It can collect in enclosed spaces. Pound for pound, methane traps far more heat than carbon dioxide during the decades after it is released. Then there is water. Rain passes through decomposing waste and picks up dissolved and suspended contaminants. The resulting liquid is called leachate. In an open dump, gas and leachate go wherever pressure, gravity, wind, and geology take them. The modern landfill would be built around a different idea. Do not pretend the waste is harmless. Predict what it will produce, then control the roots. That shift from exposed dumping to engineered containment became one of the least visible public health transformations in modern America. The federal government moved in stages. The Solid Waste Disposal Act of 1965 was the first federal law focused specifically on improving solid waste disposal practices. The Clean Air Act of 1970 increased pressure on uncontrolled burning and poorly operated incinerators. Then, in 1976, President Gerald Ford signed the Resource Conservation and Recovery Act. The law established national objectives, expanded federal and state responsibility, created a major system for hazardous waste, and prohibited open dumping. But a law can condemn an old system before the replacement is ready. The modern landfill did not appear overnight in 1976. States still needed programs. Engineers needed standards. Operators needed equipment. Communities needed permits. Regulators needed ways to monitor groundwater, enforce closure, and ensure that money would still exist after a landfill stopped earning revenue. The next decisive stage came in 1991. New federal criteria established detailed minimum requirements for municipal landfills: where they could be located, how they should be designed, how groundwater should be monitored, what had to happen after a release, how closure would work, and who would pay for care after the last load arrived. America was no longer asking only where garbage could be placed. It was asking how a landfill would behave decades into the future. That question changed the landfill from a dumping ground into a layered containment system. A modern municipal landfill is developed in cells. New cells are generally built above composite liner systems designed to restrict movement into the ground. Above them, drainage layers and perforated pipes collect leachate and carry it toward removal and treatment. Waste is placed in controlled working areas. Heavy equipment spreads and compacts it. Cover material limits, odor, litter, insects, rodents, and fire. Gas wells draw methane from the buried mass. Groundwater wells test what is happening beyond it. Stormwater systems try to keep clean rain from becoming contaminated water. Every part begins with the assumption that failure is possible. The liner may leak, a pipe may clog, gas may escape collection, the ground may settle unevenly. Rain may enter through a damaged cover. Engineering does not make the consequences disappear. It creates barriers, measurements, alarms, and responsibilities between the waste and the surrounding world. Fresh kills had opened decades before that system was complete. It could not simply be lifted and placed on a modern liner. Instead, its later history became a vast effort to control an old landfill from above and within. Gas wells were drilled into the buried waste. Underground pipes carried gas toward processing or flaring. Leachate collection systems removed contaminated liquid. Final cover systems separated the waste from the new surface. Monitoring equipment watched what could not be seen. This produced one of the strangest transformations in American infrastructure. A place built to receive what the city no longer wanted began producing usable gas and, eventually, a landscape intended for public recreation. But the buried waste did not become harmless because grass grew above it. And closure would prove that the landfill's most demanding years could begin after the final truck left. That creates an uncomfortable choice. Would you rather live near an open dump you can see, smell, and watch burn, or an engineered landfill whose risks are controlled but never fully disappear? Which should come first? Better landfills or less waste to bury? Tell us in the comments. If this investigation is changing how you see the system, like the video and share it. When Fresh Kills received its last regular barge of municipal garbage on March 22, 2001, Staten Island had carried New York City's waste for 53 years. The closure was real. The ending was not. A final cover had to limit water entering the waste. Vegetation had to stabilize the surface. Drainage channels had to control runoff. Gas wells and leachate systems had to keep operating. Groundwater monitoring had to continue. The buried mass would keep settling because decomposition and compression do not follow a political schedule. Federal rules generally establish a 30-year period of post-closure care, but regulators can extend it when a site still requires monitoring and maintenance. 30 years is not the life of the garbage. It is only a standard period for managing what the garbage continues to do. This is the next reversal in the story. A landfill can stop receiving trash and remain an active piece of infrastructure. Fresh Kills closed, but New York did not stop producing waste. The city expanded transfer stations and export systems. Garbage was compacted into containers. Trucks, trains, and barges carried it toward disposal sites and processing facilities beyond the 5 boroughs. The waste route became longer. The burden became less visible. For Staten Island, closing Fresh Kills meant relief from a system residents had lived beside for decades. For other communities, imported waste meant trucks, traffic, odors, land use, gas, leachate, and long-term responsibility for material created somewhere else. The clean curb in one neighborhood could depend on infrastructure hundreds of miles away. That is not an accident at the edge of the system. It is the system. Waste follows land, permits, transportation, contracts, political power, and the willingness or inability of communities to resist becoming someone else's destination. This is where the landfill story becomes larger than engineering. Modern disposal genuinely protects public health. It reduces open dumping, exposed waste, uncontrolled fires, pests, smoke, and direct contamination. A well-run landfill is not simply a nicer dump. It is a major improvement over the systems it replaced. But its success creates distance. A package may spend minutes in a person's hands and decades inside the waste system. Food that might have decomposed with oxygen can generate methane when buried in low oxygen conditions. A broken product becomes one invisible fragment inside a landscape that must be drained, vented, capped, monitored, and financed. The more reliably garbage disappears from daily life, the easier it becomes to ignore the volume being produced. Landfills did not create disposable America. Manufacturers, packaging, advertising, retail, product design, consumer demand, local policy, and household habits all helped create it. The landfill played a different role. It made disposal dependable. It allowed homes and businesses to produce enormous amounts of unwanted material while encountering almost none of the final consequences. That achievement changed behavior even when no one intended it to. There are alternatives, but none is consequence-free. Reuse keeps an object in circulation. Source reduction avoids producing part of the waste in the first place. Recycling can recover some materials when sorting. Contamination, markets, and manufacturing demand a line. Composting can divert food and yard waste from burial. Waste-to-energy facilities can reduce volume and generate power, but they require pollution controls and still leave ash that must be managed. Each method changes the form of the burden. None creates an actual away. That is why the engineered landfill should be understood precisely. It is not a final solution to waste. It is a containment system for material that remains after every earlier decision has already been made. What was manufactured, how it was packaged, how long it lasted, whether it could be repaired, whether someone reused it, whether a market existed to recycle it. By the time an object reaches the landfill, the system is managing the result, not choosing the cause. Today, parts of Fresh Kills no longer resemble a place that received 150 million tons of refuse. Grass covers engineered mounds. Wildlife has returned. Public spaces are opening across a landscape once defined by barges, compactors, odor, and birds circling above exposed waste. From a distance, the transformation looks complete. But beneath the new surface are layers of New York's ordinary life. Meals, mail, furniture, packaging, clothing, construction debris, objects bought, used, replaced, and forgotten. Gas still has to be controlled. Liquid still has to be collected. The ground still has to be watched. The future park depends on infrastructure most visitors will never see. That makes Fresh Kills more than a landfill or a park. It is a cross-section of modern America. On the surface, renewal. Below it, consumption. Between them, engineering. America before this transformation lived much closer to its garbage. Waste was burned, dumped, scattered, sent into water, or left in sites with little control. America after it possessed municipal collection, transfer stations, engineered cells, liners, drainage pipes, gas wells, groundwater monitoring, closure plans, financial assurance, and long-distance disposal contracts. The system made streets cleaner. It protected water and public health far better than the open dumps it replaced. It also made the geography of consumption harder to see. Every bag at the curb still begins a journey. Every clean sidewalk still depends on a destination. Every landfill is both a solution and an admission. The solution is that waste can be isolated, contained, measured, and managed more responsibly. The admission is that America continues producing material that requires land, law, engineering, labor, money, and decades of attention simply to keep it outside ordinary life. The garbage truck does not make trash disappear. It moves responsibility. The landfill does not erase that responsibility. It stores it. And long after the last load arrives, the system remains under pipes, soil, grass, and whatever America decides to build above it. If this episode changed what you see when the garbage truck arrives, subscribe to How America Became. Every episode explains how one America became another and how we still live with the consequences.